Rick Lammers, co-founder and CEO of Orchest, which is both a company name and the name of an open source project, which we will dive deep into in this episode. Welcome to the Data Exchange Podcast.
Thanks for having me. Pleasure to be here.
All right, Rick. So, your tagline, at least on GitHub, is build data pipelines the easy way.
Correct.
So, first, what is the origin story of Orchest? So how did Orchest come about? And I asked this because, as many of our listeners know, and I'm quite actually interested in many things, but one of the things I've been recently interested in is orchestration, and there's a bunch of orchestration tools, right? So
yeah, it's a very interesting subject. I can talk about orchestration for hours. I know we don't have hours, so I'll try to keep it short. But we can start with the beginning.
What is the origin story of Orchest?
So Orchest is a project that was started by me and Yannick. We're both quite technical. We met each other back in university while studying computer science. He was actually studying mathematics. I was studying computer science. He was taking some CS courses. And
go ahead.
Cool. So we were both working on the side next to our studies. And I would, looking back, call that role more of a data engineering role. We were doing this for companies working on interesting data initiatives, and they needed people who knew open source, cloud computing, data processing algorithms, mainly in the Python ecosystem, to be able to build and implement proof of concepts. And Yannick had a similar experience working on the side. And what we noticed was that a lot of the quality of the results depended on us delivering something that they could reliably and reproducibly run. And we also noticed a pattern of going back and forth between kind of iterating, freestyle, free flow, a lot of literate programming in notebooks, and trying to then take that thing that we created and making it more robust and making sure that it would handle edge cases and scale.
Couple of questions for better context. So when was this? And then secondly,
so
who were you supporting? Were they analysts or data scientists?
Who was I supporting?
Yeah, in the context of what you're describing.
I was part of a small team of data scientists or data analysts or data engineers. We were a very small team. We were doing a project for a larger company. And so I would say we were just like a group of people who knew our way around Python to implement some data analytics. But this was kind of mid-2019. And so we were both in our graduate year, second graduate year.
The reason I ask is 2019, as you know, Rick, there's already a ton of orchestration solutions.
There were. And we used a couple of them, right? So we used Apache Airflow, and we used Kubeflow was one of the projects that was at that time really kind of like picking up some attention, and we wanted to know if we could make it work. And the main issue we had with those tools were that they were quite low level, in the sense that once you started using them, you were using them a lot. Like they wouldn't get out of your way. They were like in your way a lot. And we could also kind of, looking at the documentation and looking at how to actually deploy these things in a production context, we also felt that we couldn't easily give this to, let's say, the people we were working with, that we were collaborating with of these companies. So we couldn't just say, hey, can you set up there's no tool we found like Apache Airflow and just run it on the cluster. You can also set up a cluster while you're at it. So it felt like there was quite a bit of a kind of a learning curve to those. Your sound just went very soft.
Can you hear me?
It's not very loud.
So 2019, I suspect that some of this kind of newer orchestration tools were too new, I mean, either they were just announced or they were just getting their legs underneath them. I'm talking about the generation of Prefect and Cadence and Flight and Dagster. So
Yeah.
2019 was around the time when they were maybe rolling out their first release, so a bit too new, right?
Yeah. And I actually attended a talk in San Francisco by Veal, one of the creators of Metaflow. And that was also a very interesting project that we looked at and like basically validated also a bunch of the concerns we had. Because in terms of ergonomics, I think all these tools, the more of the existing crop, but also the newer ones, usually they have kind of a persona in mind of who they're trying to optimize for. And with Metaflow, it was one of those frameworks that we saw that very deliberately thought about the needs of a data scientist. And very often a data engineer is very concerned with like getting the data from one place to another and maybe with some transforms in between, but they don't really dive into and touch the data all that much. Like for all they care, like they don't even know what kind of bytes are flowing through. Like they don't even look at the data in many cases. And
They have
data scientists,
they have very, very kind of particular SLAs, but then
they care a lot about the system performance
they're
of that
not
plumbing.
they're not deep into the data. They're not yeah.
Yeah, and if you're a data scientist, you're all over the data, right? Because this is where the value extraction comes from, like seeing that the data is of high quality, identifying data issues, discovering patterns that could lead to new kind of ideas or hypotheses to be tested. So there's a lot of there are lots of differences when it comes to like what kind of things people care about, depending on kind of what job they're performing. And we were really taking the approach of like, what would an orchestration tool look like if it's targeted towards people that do care about what's actually happening in the data and are trying to kind of in flight learn from the data that they're ingesting, that they're consuming from multiple sources, and using that as a basis to further develop the projects that they're working on. Because that was the context that we came from. It's like these kind of consulting style projects where a lot of times we get super vague questions about like what kind of things we could do. We would really need to first basically do a mapping of the quality of the data that was available. And only then we could like implement a proof of concept and show them like this is the approximate level of performance we could get for prediction or even automatic just learning and notification systems that often were the POC context. So that's where we came from.
So the orchestration solution for historically, as you point out, is targeted at data engineers. And in that context, it has kind of a set of features that cut across all these kind of solutions. So it would include something like, I don't know, a scheduler, right? So a metadata store, an executor, and some tools for monitoring and observability. So you target explicitly data scientists. I assume you need all of the things I just mentioned.
Yeah, those are table stakes requirements.
So, but
what are orchestration?
What are additional things that you need if you're targeting an orchestration tool for data scientists?
I think the big difference between Orchest and some of the other orchestration tools out there is that we really wanted to bring together that first POC iterative explorative part of the workflow, and then like moving to a more robust, well-defined cron scheduled job that can be called production grade, maybe because the code quality is higher, more abstracted, better edge case handling, more unit tests as part of that batch pipeline, like whatever you call production, but bringing those two worlds together. And the way we achieved it is by coupling a workbench, which runs in your browser, with the actual orchestration, scheduling, backend, typical features that you would find in Airflow. So it was really about like, how do we bring those two often disjoint parts of the lifecycle of a project more together in one environment?
So is it more, or the way you're describing it, is it more you have a very specific UX? But
yeah,
then the back end is kind of similar to a regular orchestration tool.
Yeah, the back end of Orchest is very similar to something like Kubeflow. We internally build on top of Argo, which is a scheduling project. So we're not even doing that low-level scheduling.
Argo workflows, which is quite proven. at scale and in production, right? So,
Argo is amazing. We love it. We love the project.
so then your UX is very kind of DAG oriented, right?
Yeah. And so one thing that, is part of the Orchest experience when you use it is that you get kind of your cloud IDE. So we've taken Jupyter Lab and really made it a first-class citizen in the process of defining and building out the DAG. And what I think is pretty unique is that often you want to be able to run these pipelines kind of piecemeal. Maybe you've just edited one step of your DAG and you don't want to go and rerun the full thing because that might take a lot of time. And you might want to just quickly see if you're catching this edge case properly now with your code changes. So in Orchest, there's this kind of what we call interactive mode where you're just changing a file, rerunning a single step in your DAG. And that kind of back and forth process is great for when you're debugging or expanding the pipeline. And then once you feel like you're confident about the pipeline, you can actually commit the code to your Git hosting VCS and deploy the pipeline to run in a more production capacity. And so that's really kind of like those two elements. People who use Orchest, they really feel like they're like almost two sides of like an integrated experience.
So what am I allowed to put in a DAG?
A DAG is basically inside.
I mean,
the DAG is a pointer
in a node in a DAG. So what's allowed in a node?
Our model is containers. So the DAG node is a container, and so whatever you want to run in the container, you can put in it. We actually are.
I can run Rust.
Yes,
SQL.
You can run Rust. Yeah,
SQL.
So we have native support for Python, Julia, or JavaScript and Bash. And the last one is kind of that catch-all that you can break out into whatever you want. You can break out into Java, Scala ecosystems. If you have code, maybe code connectors, data connectors that require this, or Rust.
What about SQL?
SQL is currently still something we recommend people to do at the language level. So Psycop G2 with SQL Alchemy in Python as a data connector. But you can use tools that operate at the SQL level like dbt in a step as well, because that bash step also allows you to use any of the CLI-based data tools out there. And a good example of that would be Meltano as well. So Meltano, we have this example up on our GitHub that shows how to run Meltano within Orchest. It's actually super simple to define your Meltano project and invoke it using Orchest. So you can build out this pipeline that does all the way from your, extract step in Meltano to your processing in a Python context.
So there's now a new generation of tools that besides, so there seems to be kind of this resurgence in interest besides building models, right? So models that you deploy in production. There seems to be a lot of new tools that enable developers, not necessarily experts in data, to incorporate ML or data science. Basically, the goal is some sort of data application or data product. So is this something, so what's the typical use case for Orchest? Is it mostly to build a model that you deploy to production, or is it something that can be used to build one of the, you know what I mean by the data product, right? So something that may be run in a browser and you're interacting with a model right away. You're just a developer. You're not an
I think a tool like Streamlit would be a better tool that you can use to build kind of like an end user facing data app. If that's like a kind of a production goal or an artifact that you could be creating in this process. What we mainly see people use Orchest for is kind of last mile ETL. So it's ETL where you're pulling data from a couple source systems, but those could already be your kind of mature, well-defined data warehouse. It doesn't have to be like very raw data sources that maybe you would just like ingest into your data warehouse using something like Fivetran. So it's like kind of the last mile ETL that is usually required for the analysis. And that last mile ETL is bundled with kind of insights analytical code. So maybe it generates a report of certain metrics you care about. Maybe it answers a couple of questions but also monitoring and alerting. So you could use that to automate insights that maybe just monitor certain values. So it's kind of like this operation style almost system that runs to check on things on the go. But we've also seen it for normal data automation, like more standard ETL, where it's just from marshaling from data from one place to another. We've seen a lot of users come from Azure Data Factory, and it's presumably because we are much simpler. So a lot of users that are really looking for like kind of a managed experience where it's really easy to just focus on what you're running in the DAG and not so much anything outside of like how do you actually run it somewhere. That those users tend to like find us and use us for various use cases that they would currently be using Azure Data Factory for. And the kind of model, like prediction model driven data apps that you're referring to, those I don't see those being built, for example, in Azure Data Factory. I also don't really see them being built in Orchest.
So it sounds like what you're describing is the sort of thing that many data scientists at companies do, which is basically they're increasingly responsible for some form of pipeline or ETL, right? So maybe, like you said, the most production grade pipelines, maybe that's still maintained by the data engineers, but data scientists now are increasingly tasked to build many of their own pipelines, right?
And I think it actually was pretty nicely described by a VP of data that we spoke to earlier. He said, look, I have my run-of-the-mill reporting analytics that I do in my standard SQL analytics setup. And if it can be done in Power BI and Tableau, I'm happy, I'll do it there. But then oftentimes we get people from the business who have complicated questions that are cross-cutting, right? Like they are not about a single kind of reporting that's just our GA, data flow or some other marketing data sources or process data sources. They're actually kind of more complicated and nuanced, and they can sometimes be very high value questions that they need answers to. Like maybe they're thinking about expanding to a new product category, and they would like the stakeholder of that project to work with the data scientist to look at the data to understand where it makes sense, what segment to focus on. So more complicated questions often involve getting data from multiple sources. And even if you answer a question like this at a single point in time, you might want to then start answering the question for the next couple of months on a regular cadence, maybe weekly, to kind of monitor to see how it goes.
And more importantly, you don't really want to kind of take your data engineers and have them do this kind of thing, right? So to the extent that data scientists are empowered and can have the tools to do it themselves, that's better.
Yeah, you want them to be autonomous. And so there's always this thing that we think about a lot is like, what did the world look like before Orchest and after? And we need to really do a good job of making sure that the world in which Orchest exists and is being used by these companies results in a much better experience with a lot less debt. And I specifically call out debt, technical debt, because what you often see is that if the need arises to set up some infra to do these kinds of like cross-cutting analytics projects where data scientists will do these types of analyses, very often they'll stand up something custom just for this project. And if that happens 4 times with 4 different data scientists, now you have like 16 different ways batch pipelines are being run, right? And so the goal is to kind of create a standardized environment in which batch data pipelines of this nature, which is analytical in nature, but some ETL involved, to be deployed in a kind of easy to use, but also standardized and well-managed sandbox type of.
And honestly, I think, and I haven't used Orchest yet, but just looking at the project, it seems like even if I do it ad hoc once and have to hand it to a production data engineering team, it's much easier for them to take what I hand them in the form of Orchest, as opposed to some kind of spaghetti code all over the place, right?
One of our goals, and I like that you identify this because it has been a product goal since the beginning, is we wanted to enforce hygiene onto the project, software engineering principles, without requiring data scientists to upend their existing workflow and do something completely different. So we do still support notebooks, but we make it extremely simple to break out code from a notebook into a script and to check it into normal Git, and even to include that process into your, code review, code monitoring using pre-commits, kind of like a normal software engineering flow, so that you can kind of start with a notebook, but immediately kind of pull your projects towards a more kind of mature code base. And you never have to kind of start over or get rid of something or move environments. It's like very much like a place where you can start, but then where you can leave a high quality result. And because projects in Orchest are just Git repositories, that very nicely integrates into any type of handoff if it becomes necessary. Sometimes projects evolve and grow and kind of outgrow the person who started them.
So let's put Orchest's status in better context for our listeners. So who's using the project, who's contributing. So as someone who's listening to this episode, should I be confident using this project? I mean, are there enough other people using it that I should dive in?
Yeah. So the types of companies we see deploying it are companies that really identified, like, for us, building our own data infrastructure is not a core business we're involved in. And so that's something we want to delegate to someone else. And so we see kind of smaller SaaS companies doing this a lot because they don't have the time and bandwidth to set up a whole data platform team that will then support their data scientist group. Usually they're hiring their first couple of data scientists to begin with. Then we see a couple of companies that are kind of off industry. So they're not tech companies, they're not software companies, they may be industrial companies. So we have like one cool example I still really like is a fishery in Norway. So we're working with a systems integrator there that's trying to predict so this is an example of a prediction project where they're trying to predict what the perfect delivery moment is for food supplies to a fishery. So they're trying to get like the notifications out to a supplier. So it's like an automation project. But you can imagine if you're a systems integrator for these types of industrialized sites with a bunch of IoT sensor data, but not really like a lot of analytical software engineering muscle in the company that you would find in a place like Netflix. You're trying to look for something that's kind of really like Azure Data Factory. It's like very managed, very simple to operate. I don't need to hire a top grade, both CS and PhD in stats person to get a useful POC up and running, because a lot of these companies want to see some early results as soon as possible because they need to build kind of confidence that this project is worth expanding and investing in. So these are examples of companies that are using it.
Maybe, Rick, you're underselling it a little bit, because basically, as you describe it, right? So you're easier to use than some of the tools that people have access to, but you're also run on multiple clouds. There's no
we're cloud agnostic and open source.
So so you're open source, you're cloud agnostic, but you also are focused enough so that the usability is a big selling point, right?
Yeah, we did a user survey recently among our users, and we asked them, like, what's the number one reason why you use Orchest over some of the alternatives that are available for orchestration in general. And a lot of answers just simplicity, gets out of my way, it just works. Like, they were very happy with not spending too much time with their orchestrator. And as weird as it sounds, like, we like that we can get out of the way. We don't want to be in the face of a user. We're happy being invisible in the background and making sure your pipelines run, and when they fail, that you get a message, etc.
So who's contributing to the project right now? Is it mostly still you and your?
So we picked up some external contributors along the open source ride. People found the project. Usually they find a small issue in the README or in the documentation, but we've actually had code level contributions around certain features in the GUI. Some people with front end skills pitched in, and API SDK fixes. But the main development by the project happens with the team of Orchest. We're a group of 10 people, and we contribute most of the code of the OSS project.
So what's the difference between Orchest open source and Orchest the company?
So Orchest as the company is building building Orchest itself, but we're also building on top of this what we call the open core, similar to something like GitLab. a proprietary product that we would like to sell to a subset of the users who care for the functionality that version brings over the open core. We've also been very
wait. So what is the functionality beyond the open core? So you have to elaborate.
So as a company, like I mentioned, we got started with this, full time in April 2020. So we're super early stage. So at this time, we just have the open core.
Okay. So there's no. So what do you anticipate will be in kind of the enterprise version of Orchest? Is it more things around permission, security, collaboration? So
yeah, a lot of it has to do with kind of throwing up Chinese walls. That's a good way to explain it. So permissions and kind of granular detailed access controls, because a lot of larger companies that start using these types of tools, they have a lot of internal accountability and restrictions on what they can and cannot do. And so because Orchest is also a runtime for your pipelines, it also contains like environment variables and secrets. So we expect most of the functionality of the paid product to be geared towards kind of more sophisticated and granular access controls and security requirements. But we're a startup, right? So we're also just kind of experimenting with what we do as a paid product. And what we've noticed a lot is that there's a strong need for guarantees or having someone available with deep expertise in a system to be available when things don't work. So we're also really looking at kind of a support model where sophisticated companies have highly valuable. We have companies now telling us like, look, we're running critical workloads on Orchest now. We would feel very uncomfortable if we don't have someone that is immediately available to help us troubleshoot if things go haywire, whether that's our own fault or because there's something in the software. And so giving guarantees to companies around this is something that we're exploring as a monetization option as well.
So you alluded to the fact that you folks actually leverage Argo workflows.
Yep.
So in many ways, then many of the kind of more, I guess, gnarly engineering questions around scaling, retries, fault tolerance, that's all Argo.
Yeah. So we early on had the definitional model because Orchest is declaratively specifying what is the DAG, right? This is just a data structure that defines fully what is the workload and what are the dependencies. And we early on defined this to be around the concept of containers that could live anywhere. So they don't have to be on a particular node. They can actually take advantage of particular node characteristics. If you want to have, a very beefy node for a certain step because it requires a lot of memory. And so a lot of, in that sense of the declarative concept, maps to lower level executors or workflow runtimes like Argo. And so if you really kind of want to summarize it, like we're almost like a GUI for Argo. So if you think Argo is a bit too low level to expose to a data scientist, you can use Orchest and map to Argo itself. And that definitely gives us benefits because we do not have to reinvent the wheel at the lowest level. And Argo built on top of Kubernetes, and for the development workflow, we also build on Kubernetes. And one thing that, for example, we add, which is quite significant, which has nothing to do with Argo, but is taking advantage of the container ecosystem, is the way we handle environments, which is also I think, quite unique to Orchest. We allow the data scientist to build the container image directly from the browser, and you can actually build from the browser, stream the output to your browser client, and you can see the output of the container build process to see to validate if things are working, if you get any error messages, and to kind of map that kind of UX to a Kubernetes scale cluster where the image distribution is happening at a high performance rate, where those images are being versioned in the correct way. That's all kinds of like UX improvements that would typically take a lot of work for the platform team to implement themselves. So we kind of see a lot of duct tape solutions in that area where we've really done kind of a proper wrapping of container image building, which we extend build on and Podman tools for that.
So what about if I need to scale out? I need distributed computing that's fault tolerant. What do you folks do there?
So there are basically two ways you could go about this at a high level. The first is if you are running Orchest where you have many steps that you want to run in parallel, and you can just specify the DAG, and the Argo scheduler will just assign them to the nodes that are available on the Kubernetes cluster.
Or
And
one node might be distributed training.
Yeah, so that could work as well. And that's kind of the second approach that I'm alluding to, which is if you want to use a worker model where you have distributed algorithm fan out, you can just build on top of frameworks like Dask and Ray that support this, because those can easily be embedded into an Orchest pipeline. And so what we even have as an example on our GitHub is how you can actually fan out the distributed training process to a coiled cluster that's dynamically spawned for that pipeline step. So you can actually just have a step that creates a cluster, sends the compute job to the cluster, and collects the result. So you can even like distribute out some of the computation to a separate computational backend by tapping into these frameworks like Ray and Dask that you've probably heard of as well.
Yeah. Full disclosure, I'm an advisor to Anyscale, which is the company behind Ray.
We like both projects a lot.
And I'm also an advisor to Databricks. All right, so let's see. So what's on the near-term roadmap?
So we just released our Kubernetes operator, which makes it very easy to deploy Orchest to existing cluster setups. So it makes self-hosting at scale a lot simpler. One of the things we've been getting questions about is like, how do I automate more of what I've built in Orchest? Usually you'll have kind of a multi-persona group working on these projects, and then the data scientist is super happy because they finally have something they can easily drive and really plays into like their preferred workflow. But then there's some, data engineer that says, look, I would like to read out the status of the system. I'd like to connect with it, trigger it automatically, these types of automation questions. So we're releasing the first public API that's going to just, basically provide a REST API to all of the surface area of the features you have in Orchest. So you can trigger both from the GUI and from an automation perspective using normal REST calls. That's something that's coming up. And we've seen a lot of requests around making kind of observability and monitoring of the production jobs.
I was going to ask, because a lot of these orchestration tools, honestly, they really are very proud of their observability, monitoring, and dashboarding tools. So what do you folks have in that area?
So we really started our focus on a great developer experience for the Workbench side, where you're building out the DAG and you're defining all these steps. But we soon realized that the companies that were then like happy with the DAG and now running it in production, they wanted to have more robust controls and insights into how these things are running. You have to imagine a lot of these pipelines actually run in general purpose language context. So they might spin up a Python interpreter. And so they're interested in things like, okay, what is my memory doing? Like, am I close to going out of memory? Are there certain bottlenecks in the performance of my pipeline? Are we seeing regressions? And so having more mature and automated kind of reporting and even just like simple visualization of the performance characteristics of the pipelines that are running in a scheduled capacity was always on our roadmap, but that's something that's now nearing on like the very short-term roadmap that we're delivering. So
is the open source project, is that meant to be used by one person, or how do I collaborate in the open source project? Is there like a team console where there's an admin who manages? So how does that work in the open source?
So the web client talks to what we call the Orchest control plane, which is actually supports multiple user sessions concurrently. So you can have multiple people logged into the same control plane. And then that basically acts as a kind of a manager of the Argo workflow. So you can have multiple people working on different projects at the same time.
Everyone is co-equal. There's no admin.
Yeah, there's right now, there's no differentiation between different users, but you can have multiple user sessions.
This has to change for the enterprise version.
So we're trying to figure out like what kind of controls make most
Yeah.
sense to people, and we're really using the kind of the active users that we now have collected over the first 2 years is like what kind of granularity are you seeking, and that's also kind of a learning process for us because we get very different answers and we need to generalize them to a single set of features that provide the value to like 90% of the use cases we hear. The 10% that we don't think make sense, we probably will discard them.
By the way, a few years ago, I was talking to the founders of Databricks, and we were talking about the state of data pipelines and data engineering in general, and how we need better tools. And I think people have started to build more of these tools since then. And I know Databricks, inside Databricks, they have these tools now. But the idea is, how do you bring software engineering rigor into how we build pipelines? And you've alluded to this already, right? So I think a tool like Orchest actually can help you do that, because you have better visibility about what you're doing, and you know where things are slow, where things are failing. Maybe you can even do the equivalent of unit testing, integration testing, right?
We actually like this pattern of testing on your live system in a way that doesn't affect the runtime of the pipeline itself. And the way that works in Orchest is any pipeline step. So I think everybody learned from Airflow that you need to consider data passing between pipeline steps as a first-class concept, which is the case in Orchest. And it's especially important in a distributed system context because these containers are running on different nodes potentially. So you need to think about how does data move from one node to the next. And so the way we've designed it in Orchest is that you can pass data from one step to the next, but there can be n number of consumers. So you can have one step that is basically your normal pipeline flow that does the data processing and does something with it, but you can add auxiliary steps in Orchest that basically assert a bunch of things about the data coming in. So they can assert non-values, they can assert ranges. You can use any third-party framework for this as well. So you can use tools like Great Expectations or other even basic Python unit testing tools to basically then have as part of your pipeline these checks and balances that really just go through the live data that's flowing through the system. But because these containers are really kind of separate from one another per step, these containers that do the test running are not affecting the runtime performance of your primary DAG. So we really want to bring in like,
but also Rick is Orchest is designed so that you can do this much more easily and naturally, right?
Yeah, it's all about making that simple.
Yeah.
And so we have this very simple mental model. I think it's the simplest we could come up with that really is nice and generic, which is a file is a step in a DAG, and a DAG can have multiple nodes with the same file if you write files more generally in a more generic way. But the concept is really like running a file in a container somewhere in your cluster, and that really maps to a whole large number of open source projects that you can then go and take advantage of. And you can kind of piece together the tools that make sense for your project. Sometimes that includes using something like DBT or Matana, but sometimes it's pure Python, and that also works.
And actually, many of our listeners know that I've talked about this in the past, but to the extent that the media and popular media at least is so focused on models and all of these things, right? But the reality for data teams is it's all about pipelines and data quality, and because I think we're getting to the point where we have either decent AutoML tools or decent model hubs that give you a starter model that you can tune, but it's really how well do you know that your data. How good is your data?
If you're a business owner and you're looking at organizing a bunch of data initiatives, usually you want to think a bit about like, okay, what am I going to get out of this? And a lot of times companies are starting from a place where they might not even be looking at a whole host of data that they have. So they'll look for the kind of lowest hanging fruit data initiatives that they have within the company that can have a meaningful, can contribute to a meaningful difference to the bottom line. And that almost never is like, let's build a sophisticated LSTM time series model that uses pre-trained NLP models that require GPU for inference. Like that's a very fun project to work on, especially if you come out of academia where a lot of these kind of more sophisticated techniques are analyzed. But what we've actually, we love this stuff too, right? We came out of CS degrees. We really watched kind of all the deep learning revolution unfold. But then when we talk to real teams, they basically have a business question and they just want to get, some data in some shape into another shape so they can answer a basic question. And as long as you're not doing those things, then usually the more sophisticated thing doesn't really quite make sense yet. And so that's what we are seeing most in practice is it's basically companies just using disjoint data sources, kind of siloed data, bringing them together to answer basic questions about the operational reality of, what is objective reality telling us about what we're doing with the company, and how is that going to help us make better decisions and move faster, grow faster as a company, as a business. And usually that's analytical and not.
Yeah, I just did a deep dive into the data integration space, and it's really kind of vibrant. I mean, there's the general purpose tools, there's the orchestration tools, and then there's the domain specific data integration tools. And, just when you think that data integration is kind of a done, mature space, but it's really kind of a very active space now with, before you had ETL, now you've got ELT, you got reverse ETL.
And it's also because
and then the whole resurgence and interest in data quality, right? So because of ML, right? So I mean, it's a really exciting space. Yeah.
I think there are a couple underlying trends that are making that interesting and creating some sort of resurgence in those areas. And like, for example, just take the cloud database, the cloud data warehouse, like Snowflake, where you can just ingest as much as you want, and you can start running all sorts of interesting queries on top of your data with very low complexity compared to what you had to do to get to those types of analytical results in the past. So it has become cheaper, but at the same time, you see kind of data diversity exploding. There are so many systems. I really like this quote from a very senior cloud engineer who I think spent time at Google and Oracle, like lots of large companies. And he said, like, we're not even talking about nines in terms of uptime of cloud systems. It's really kind of a duct tape of all these systems that are coming together. And there's so many different storage layers, so that if you want to answer analytical questions, you need to be able to go cross-cutting between different SaaS sources. And usually you can bring those together in a single data warehouse, but sometimes it makes sense to query directly from source. So there's kind of a bustling ecosystem of data generation, which requires different approach to analysis, is what we're kind of seeing.
As someone who helped write the post for Databricks on Data Lakehouse, I have to give the Data Lakehouse a shout out. I think that will ultimately be kind of the winning model, where you have structured, unstructured, you can run SQL, you can run Python, you can do ML. Anyway, but actually, as you were talking, I was smiling because basically I imagine you're running a small startup. Make a list of all of the SaaS tools you use to run your company, from HR to.
It's huge.
It's huge, right? And then someone wants to pay you, then you have to sign up for that SaaS. You just start losing track of all the things that you're using, right?
Yeah, it's there are lots of tools, and we really try to take a deliberate approach of, where do we store the source truth data, to also make sure we have an analytical stack ourselves about, what we're doing as a company, how we're performing in all these areas, to make sure it's manageable. So I would say there is really this kind of tendency, I feel like, where people are trying to do as much as possible in a single tool, like GitLab as a proposition, to put your version control and your DevOps and your deployment, like all these things, into a single platform. I think is becoming a stronger and stronger argument, because managing all these different vendors and tools is complicated, but we want to make sure that users that need to deal with these different sources are able to do so with a simple system that runs their batch.
Yeah, and I think that's ultimately why I think these point solutions. You know, to some extent, the notion of the modern data stack is kind of this notion that you have access to all of these best of breed solutions and you can pick and choose. And by the way, the funny thing about that is whenever you see a post about it, about modern data stack on Reddit, right? So someone will say, "Oh yeah, we just did the modern data stack. These are our choices for orchestration. These are our choices for ETL." So, and someone will, the first comment is, "That looks complex."
Yeah, I'm not sure if people are happy with the modern data system.
I think to your point, I think there's going to be some kind of consolidation where people will try to do use simpler architectures and
it's why we bet so much on Kubernetes, because what we really want to empower people to do is to put the orchestrator wherever their existing data stack lives. And so we've seen a lot of times where they already have some existing system, and instead of saying like we'll add another independent system that you then also need to start like connecting with and bringing together, we want to be able to be a drop-in orchestration tool that can sit within whatever you already have decided to build, because we understand how many complicated trade-offs there are to make when designing your data stack, and we didn't want to contribute one more complicated factor. So we're very much just kind of like we're running containers on a Kubernetes cluster for you, and we provide a nice GUI for you to do that, but we're in a way really well scoped so that you can play well with the other components that you're interacting with.
So very briefly to close, Rick, who should try Orchest today? Is it someone who just is working on a laptop, or does it have to be someone who's working on a cluster? Or
we go all the way from a single laptop to a very large scale Kubernetes cluster. So you can install Orchest on your own machine. We have a simple convenience script installer that will use Minikube to run Orchest on your device. Usually that's what people do for evaluation. But if you're a data scientist and you find yourself writing ETL like code and you want to break out a single notebook or script into multiple steps, and you want to schedule that execution, I think that's a perfect scenario in which you would get a lot of value out of having this kind of single platform, especially if you're going to work in a team context where you have multiple people. The ideal team size to use Orchest, I think, is like between 2, 3, 4, 5 people. That will really save you a lot of headache in having to set up your own batch data platform that you could piece together using lower level open source solutions, but then you're just kind of reinventing the work that Orchest has done painstakingly, I may add, for the past 2 years. And we're really looking forward to get more feedback from the community about what are some of the areas that they're still struggling with, even after utilizing the features we shipped. What's something that we can add on top of that, because we're getting great ideas and community feedback about what we've created so far. And with that, thank you, Rick Lammers. Thank you for having me.